We all know that EVs are growing in popularity, and Tesla has been spearheading that growth and attention. And as the EV market grows and matures, so does the opportunity for other EV-related businesses. And one of those opportunities is around EV charging, which is an area that the industry is still trying to expand on to address things like competing charging standards, speeds, and customer range anxiety. But what if you could charge wherever you park, wirelessly? How would that change owning and using an EV? And what would something like that unlock for the future that's not possible with current charging methods? I visited a company in Watertown, Massachusetts that has answers to some of those questions. I'm Matt Ferrell. Welcome to Undecided. I visited the company WiTricity in Watertown, Massachusetts to find out more about how wireless EV charging works and what it might mean for the future.
Well, I'm Alex Grusin. I'm the CEO of WiTricity. We were founded back in 2007 within the physics department at MIT around an invention of how you could move electric power over a distance efficiently. For the years since, we've been doing two things, right? One is sort of advancing the technology, figuring out how much power you could move, at what frequencies you operate at, and how small can you make it, and sort of basic technical challenges. And then figuring out, so where does that fit a market need, looking for what the target market is. And at the very beginning, it was sort of anything that has a battery or anything that has a power cord. And over time, you figure out, okay, this is where sort of the perfect product market fit is. And for us, it's really around charging electric cars, moving kilowatts of power, to a car, and just making the task of charging your car something that just becomes transparent. It just goes into the background. You just never have to think about it ever again.
But how does it work? And how efficient is it? It's a little more complicated than the Qi charger you might use for your phone. So Alex walked me through the basics of how the system is set up and works.
So what you see here are examples of our reference designs, our sort of production-ready designs for the ground pad that can be completely, immersed in 5 feet of water or embedded in the ground. The power electronics is what would go on the wall and attach to the grid, and then what would go on a vehicle. And so receiver coil, and then some power electronics, and this would just mount underneath the vehicle.
Okay.
And coming out of it right over here is, you can see the orange connector. Orange always means the high power, high voltage connections. That just feeds directly into the battery management system.
So for this kind of technology, how efficient is it compared to something like plugging your car directly in?
So that was really the sort of amazing invention and insight that came out of the team at MIT, was that we have an ability to move power to the car just as efficiently as if you'd plugged in.
Okay.
And at that point, most people just kind of like, how's that possible?
Right.
We have this one air gap, which from our ground resonator to our vehicle resonator, so from the charger to the receiver, is about 99% efficient, just coil to coil.
Really?
And we don't need an isolation transformer, which is a kind of a lossy element in a traditional charging system. So at the end of the day, we're equivalent. From the grid to the battery of your car, which at the end of the day is all that matters, right? From the grid to the battery, we're 90 to 93% efficient end to end.
That's impressive.
Which is the same as plugging in. And
right.
In fact, traditional chargers range from about 88% to about 94%. Maybe the best in class in the world is in that 94, 95. So there's no compromise. There's really no net loss from going wireless.
Right.
For every software load, for every redesign of an electronic circuit, we sort of validate that under all the conditions, all the positions and offsets and heights, that the system delivers equivalent efficiency and performs well, and so A lot of testing and validation going on here.
While it sounds a lot like the wireless charging we're used to seeing in our phones, it's not the same thing. WiTricity is using something called magnetic resonance, which I asked Alex to walk me through. That kind of takes me to my next question, which is, we were talking about before we actually started filming, which was the difference between like induction charging, which is what most people are used to, like with their toothbrushes or the Qi chargers for their phone,
Right.
versus this. And with Qi charging, I know with a phone, it's less efficient than plugging it in. So
Sure.
What is the difference between that and what WiTricity is doing
Right.
with their technology?
So our technology is called magnetic resonance wireless power transfer, or often just called magnetic resonance. And it builds upon a history of induction charging, but it shifts it in a pretty radical new way, which is it makes the two coils each very efficient resonators that operate tuned to a particular frequency, right? And by making them efficient resonators, it's kind of like pushing my kid on a swing.
Okay.
Where little taps of energy could result in the swing, really moving.
Right.
In this case, because the source, the pad on the ground, and the receiver that's built into the car are both tuned to the same frequency, around 85 kilohertz. The energy, and each of them is a very efficient harmonic resonator. The energy moves efficiently between the two. Traditional induction, you have to have sort of perfectly matched coils. They have to be very close to each other, and they have to be in perfect alignment. But with magnetic resonance, you don't need that. You can have offsets, you can have different heights, and you can have different sizes, just as long as you keep them sort of operating in the same sort of operating frequency. And that was really the breakthrough, and that's why we started on our journey developing wireless charging solutions back in 2010. And since that time, we've been working with all the global automakers on a global standard for our technology for wireless charging. So,
what is the name of that standard that you're working on?
Great marketing within technical standards committees. It's called the J2954 standard.
It's really catchy. It catches right on.
I think we'll end up coming up with a
right.
a nice marketing name for it. We actually already have a logo for it. So a name I'm sure will follow. But at the end of the day, the point is you'll be able to, install a charger, and any make of vehicle, we'll be able to park on it.
Right. Now, with such high power being transferred, what about safety?
So it's a common question.
Yeah.
Right. The way I like to think about it, the way we've done all the testing and validation, is that this is like having an induction cooktop in your kitchen.
Right.
All the same rules and regulations that apply for that apply for us with wireless charging. Low frequency magnetic waves.
Right.
It's not ionizing radiation. It's not radio waves. It's low frequency magnetic waves that are all contained and held in the space right between the coils. Just like in your kitchen, all the energy really is between the cooktop and the pot or the pan.
Okay. Does this support vehicle to grid? Because I know that's a standard that's really starting to catch on in Europe. Not so much here, from what I've seen.
Well, no, I think it's early days, but it's starting.
Yeah.
So one of the things we proved to the industry last year was that wireless vehicle to grid was possible with industry standard wireless charging components. Right? So we actually were demonstrated by Honda in their booth at CES last year.
Oh, wow.
And the ability of a car owner or a fleet owner to sell energy back can be lucrative. Maybe it pays for your charger or pays for your infrastructure.
Right.
One of the things that isn't being talked as much about vehicle to grid is the fact that the car's got to be plugged in. And that battery in your car is most useful to the grid when it's pretty full. And when your battery's pretty full, people don't plug in.
Right.
So how do you fix this, right? People aren't talking about that.
Yeah.
So this is what's exciting about wireless vehicle to grid, which is the car's there, it's available. And this is what we demonstrated with Honda, was that you can very quickly turn on the system, have the power flow the other direction just as efficiently as we've shown we could flow this way. So what it means is every car, without any user intervention, will be available for the grid on demand. Okay. So I think that wireless just supercharges the concept of vehicle to grid.
Right.
Yeah.
So you've also, like you mentioned, Honda. You're partnering with different car companies. I
Sure.
know there's a BMW. I can't remember what the model is.
Yeah. So in 2018, they launched the world's first sort of commercially available automotive wireless charging solution on their 530e iPerformance vehicle.
Okay.
They have a great tagline that says, "BMW Wireless Charging makes charging easier than refueling."
Right.
Right. So let's not keep trying to recreate, this gasoline set of experiences. I mean, I think EVs enable something new. In this case, just never having to think about charging. They launched that vehicle as a pilot in Germany, in California, and in China. And even in China, they rolled it out to a car sharing service. So if you think like a zip car kind of thing.
Yep.
And then every time the car got parked back in its spot,
right back up.
It's charging. So again, no dependence upon the user to do something. And whenever you go to the car, it's charged and ready. We have many other automakers working with us to go roll out this technology, and sort of the next wave of standards-based solutions, again, around that SAE standard that's been published. Hyundai demonstrated our technology at the Geneva Motor Show, Honda at CES. Nissan has been public about their support of all of our industry standard work. And we even have customers, OEMs in China, that are driving really aggressively to come to market in the next 2 years.
It's pretty clear how beneficial this can be for car owners today, but what about the future? Wireless charging struck me as an obvious benefit for autonomous driving, but Alex pointed out a few more areas that I hadn't considered. One of the things that really, when I was researching you and looking into the company, that really sparked my interest was autonomy is coming. It's not if, it's when. Right. And one of the big questions is, how do these cars charge themselves when they're driving around? And when I saw that you were jumping, I was like, well, that's how they probably are going to do it.
That's how they're going to do it. Yeah. We all know the vision of robo-taxis is real, and I think I think some thought it would come sooner, some thought it would take a long time. I think within the next 5 years, there'll be sort of relatively broad deployments, at least in geofenced areas, specific service areas, and there's no one to plug them in. So the ability to just pull over and power snack, which is what I call it, right? Just to charge up in between rides as needed on demand in the service area, and not having to expend energy to drive through traffic to some depot and then come back into the service area. I think wireless charging, is the answer. And so it's a little bit self-serving, but I think that, right now all the conversation is like LiDAR and radar and machine learning and all of the optical sensors and the like. I think wireless charging will be just another key technology of the future of autonomy. But before we get there, what is happening much sooner is auto valet, right? The self-parking.
Yes.
All right. So even the Super Bowl commercial from Hyundai, right?
Yeah.
Smart Park.
Yeah.
All right. So that's very dear to us here in the Boston area, right? But perfect application, right? Send the car to go park in the garage. Again, there's no one to unplug it if it's plugged in, to come to you, and if it goes and parks itself, there's no one to plug it in. So wireless charging is perfectly suited for that. And Hyundai actually published a beautiful video on YouTube as well that shows the combination of our wireless charging with this self-valet or auto valet application. And we have customers, actually one of our customers in China that's already deploying this, and they are going to all the parking garages of every apartment building across China and radar mapping. Just like there's Google Earth and Google Maps, they're radar mapping all the parking garages to enable this self-parking auto valet functionality.
Wow.
And they're adding our wireless charging to that.
Wow, that's incredible.
Yeah. So it's exciting.
That's really cool.
We need to take care of taxis. And so taxis fundamentally have this conflict in that time that they're charging is time that they're not making money.
Right.
So one of the unique things that we can do with wireless charging is actually electrify the taxi queue.
Okay.
So if you imagine, this being, a taxi queue at a train station or an airport, right? Without changing what we would mount on the vehicle, we can actually electrify that queue.
Right.
And as the taxi inches its way forward, waiting to get to the front for their passenger, it could be charging.
Right.
If you're going through this queue, a couple times a day, now your vehicle can make it from the morning, all the way to the end of your shift.
Right.
And it's not a series of discrete charging places they have to stop. We actually can make it continuous.
Okay.
With a new architecture of sort of charging coil that can be embedded in the ground of that taxi queue. The technology has been proven. We actually had a test track that was built in France and showed that driving over 60 miles an hour, over 100 kilometers an hour,
right,
the car could be fully charged. In this case, 20 kilowatts of power being delivered to that vehicle as it sped along at 100 kilometers per hour.
That is
And so
awesome.
it's technically completely possible.
Right.
And I think economics are going to drive us to attack this urban challenge and help make the electrification of taxis something very real in the near future.
What are some of the biggest obstacles that you see ahead of you with this technology?
So in terms of getting deployed to market,
right,
we've been working for about 8 years on a standard.
It's getting that standard.
Getting the standard locked in has been a challenge. It's finally been published, so great progress.
Yeah.
And then some of the automakers have been waiting for that to sort of lock in before they sort of committed to production. So that's been really important to us. After that, our technology is complete, the solution is complete. It's really this push to continually, drive costs down, right? So right now, adding wireless charging to your car is probably like adding those 20-inch wheels with the high-performance tires, or like adding rear seat entertainment, or some kind of like options package, like a convenience package, is kind of like the cost level.
Okay.
And I just need to keep driving it down, right. and that will happen naturally over the course of the next few years. I think the first sort of standards-based major OEM deployments are going to be sort of the end of 2021 and through the year of 2022.
Oh, that's exciting.
So my history is in the PC industry, and like I used to ship 3 complete product lines a year. And so for me, working in the auto industry these days, now it's flipped, right? It's like one project, takes like 3 or 4 years to actually get to fruition.
Right.
And we've been working on it for a long time, but it's finally happening.
Yeah, that's really exciting.
Yeah.
Well, I really appreciate you taking the time to talk to me.
That's great. I appreciate it. Thanks for the interest.
I'd like to thank Alex Grusin and WiTricity for taking the time to talk to me and show me around their offices and lab. As the EV market continues to grow and mature, we're going to see more and more companies like WiTricity filling in gaps in the user experience to unlock whole new ways to use our cars. And it's important to remember that we can't and shouldn't try to map our current car experiences onto the future of electric vehicles. We may be used to stopping at gas stations to pump gas into gas tanks, but that doesn't mean that's how it always has to be. If WiTricity has their way, we won't really need to think about charging our cars at all. So what do you think? Would you be interested in wirelessly charging your car? I can tell you I'm really interested in the idea of not having to think or remember to plug in my car, so I can also take advantage of something like vehicle-to-grid power. And jump into the comments and let me know what you think. And be sure to check out my new podcast that I started with my brother Sean. We discussed the previous week's video and some of your feedback. You can find out more at stilltbd.fm or just search for Still to Be Determined on iTunes, Stitcher, Spotify. It's pretty much everywhere. And if you think I've earned it, I hope you'll consider subscribing and hitting that notification bell to get alerts when I post a new video. Without that bell, you might miss out. Now give this video a thumbs up if you liked it and share it with your friends because it really helps to support the channel. And as always, a big thank you to all my patrons. I've got a lot of exciting videos in the works, and I say this every time, but your support is really making it possible. Be sure to check out my Patreon page for additional details about joining the crew. And as always, thanks so much for watching. I'll see you in the next one.